Welcome to the deep dive. Today, we're going to be exploring this really cool research paper.
Yeah.
It's called Predictable Scale, Part Optimal Hyperparameter Scaling Law in Large Language Model Pre-Training.
Catchy title.
Yeah, a little intimidating, yeah, right?
Yeah.
But the stuff in here is really interesting, especially if you're following in the world of LLMs.
Absolutely. And, this paper really tackles a challenge that anyone working with LLMs is going to know.
Right.
Hyperparameter optimization.
Yeah?
You see these models have a ton of different knobs and dials,
Yeah.
hyperparameters you need to adjust
Yes, that bag.
to get the best performance. And
To get the best performance out of them, yeah.
two of the most important ones are learning rate and batch size.
Okay, so learning rate.
Yeah.
Now, for our listener out there who's maybe not, super deep in the weeds here,
Yay?
you can think of learning rate as the speed at which the model learns from the data.
Yes.
So if you set it too high,
Yeah.
the model might be kind of like jumping all over the place and never really getting it. Set it too low, it's going to take forever.
Exactly. And batch size determines how much data the model processes at once.
Okay.
Larger batch sizes can really speed things up, but you need more memory and computing power.
Uh-huh.
The problem is finding the optimal learning rate and batch size is usually really time-consuming and expensive.
Yeah, it's like you're trying to bake a cake and you don't know how much flour to use or how long to bake it for.
That's a perfect analogy.
You just end up with a lot of bad cakes.
Exactly, a lot of wasted ingredients.
Yeah.
The traditional method is a lot of trial and error.
Right.
What we call grid search, where you just try out a ton of different combinations of learning rate and batch size.
Yep.
But as LLMs have gotten bigger and more complex, this is just not practical.
Right. And so this research really tackles that problem head on.
Yeah.
And they set out to find a better way. And to do that, they trained thousands of LLMs.
I know. It's amazing.
Can you imagine the compute cost?
They actually said in the paper that it cost over $1 million in compute. But they found something fascinating, a formula they call step law that can predict the optimal learning rate and batch size just based on model size and dataset size.
So instead of spending weeks or months like fiddling with all these different parameters,
Right.
you can just plug in a couple numbers and get a good starting point.
Exactly. And the formula itself is pretty elegant.
Okay.
For optimal learning rate, it's eta of n, d equals 1.79n to the negative 0.713d to the 0.307, where n is model size and d is dataset size.
Okay, so I'm not going to lie. Those equations, they hurt my brain a little bit.
Sure.
But the point is you don't have to be a math whiz to use this research.
Exactly.
Yeah.
It's about having a good starting point,
Right.
and this formula gives you that.
Yeah.
Now, what's even more remarkable is they discovered something about the loss landscape for these hyperparameters.
Okay, so you mentioned loss landscape earlier.
Yeah.
Can you remind our listener what that is and why this is important?
Of course. So imagine you're trying to find the lowest point in a valley.
Okay.
That's kind of what training an LLM is like. Oh, you're trying to find the point where the model performs the best at the point of lowest loss.
Right.
The loss landscape is a way to visualize this,
Okay.
like a map of all the hills and valleys.
So if it's a nice smooth valley, it's easy to find the bottom.
Exactly.
But if it's like all jagged and crazy,
It's much harder.
yeah.
And what they found is that the loss landscape for these hyperparameters is convex,
Okay.
meaning it's smooth.
So there's one best point and it's pretty easy to find.
Exactly.
That's
Well,
great.
This is different from a lot of machine learning problems where the loss landscape can be really complex.
And so this is huge. This is like a big deal that it's convex.
It is a big deal.
Yeah.
It makes things much easier.
Now, before we get too deep into the convexity thing,
Sure.
I'm curious, how did they even come up with this step law in the first place?
Yeah.
Did they just like randomly train thousands of LLMs and hope for the best?
Not exactly. It was a really methodical process.
Okay.
They started by training LLMs of different sizes, from small ones with millions of parameters to huge ones with billions of parameters.
Okay.
And they did this across different data sets, changing how much data the models saw.
So they're really systematically exploring the relationship between model size,
Right.
dataset size, and these hyperparameters.
Exactly. And by analyzing this massive amount of data, they were able to find these power law relationships that are captured in the step law formula.
That's really impressive. It's not every day you see research on this scale.
I know.
But here's a question.
Yeah.
We know they tested step law on a bunch of different LLMs,
Right.
but what if you're training a model with a slightly different architecture?
Yeah.
Does this step law thing still apply?
That's a great question, and they actually anticipated that.
Okay.
They wanted to know how universal step law is.
Right.
So they tested it on models with different architectures, different ways of organizing the model's internals.
So they were really trying to push it to the limits and see if this holds up.
Exactly.
Okay, what did they find?
Well, the results were pretty amazing.
Okay.
Even when they introduced big variations in the model architecture, the predictions made by step law were still really accurate.
So it's not just specific to one particular type of LLM.
Exactly. It seems like a more general principle.
That's incredible. So someone could listen to this deep dive
Right.
and then go and apply step law to their own model, even if it's not the exact same model.
That's right.
That's really cool.
They also tested it with different levels of sparsity.
Okay, now I'm not sure if our listener knows about sparsity.
Right.
Do you want to just break that down quickly?
Sure. So in a dense model, every neuron is connected to every other neuron in the next layer.
Right.
In a sparse model, you prune away a lot of those connections,
Yeah.
making it more efficient.
Okay.
So they wanted to see if the level of sparsity affects the accuracy.
So they tested it on models ranging from very dense to very sparse.
Yeah.
Okay.
That's cool.
And they found that even with these variations, step law still performed well.
Really?
They used a technique called mixture of experts, or MO.
Which lets you have really sparse models, and even there, the predictions were good.
Wow, this step law is looking pretty robust.
It is.
Yeah.
It seems like it's pointing to some fundamental principle about how these models learn.
So it's not just like some quirk of the data or the specific models they use.
makes that
There's
right.
something deeper going on.
Yeah, it makes you wonder if there are like universal laws that govern learning in large models.
It's a really interesting question, and one we're going to have to save for another time because we are out of time for this part of the deep dive. But we'll be back in just a moment
Sounds good.
to continue this fascinating discussion.
Looking forward to it.
All right, see you in a minute.
You know, before we jump into like the practical side of things, there's something about this step law that I find really intriguing.
Oh, yeah, like that.
Well, it's the fact that it uses such simple inputs, just the model size and the dataset size.
Yeah,
It's almost like a hidden code, you know, a key to unlocking these complex models.
it is pretty elegant. And it makes you wonder, why didn't we figure this out sooner?
Right. It really speaks to how fast this field is moving. You know,
Yeah.
LLMs have grown so quickly, and with that growth, we need new tools.
New methodologies.
Yeah.
Absolutely.
This research is a great example of that.
So let's talk about those practical implications.
Okay.
Imagine you're a developer working on some cool new AI app. Or maybe you're a researcher trying to, push the boundaries of what LLMs can do.
Right.
How does this research actually help you in your day-to-day work?
Well, think about all the time and resources that you normally waste on hyperparameter optimization.
Right.
Instead of spending weeks or months running all these experiments,
Yeah.
you can use step law to get a good starting point.
So it's like having a roadmap instead of just wandering around in the dark.
Exactly. It streamlines the whole process.
And this is especially important for smaller teams or individuals who, maybe don't have the resources of like a big tech company.
Absolutely. It really levels the playing field.
Right?
It allows more people to get involved.
But is there a risk of like overfitting if we rely too much on step law?
That's a good point.
What if our specific problem or our data set has like some weird quirks that the formula doesn't capture?
Yeah, you always have to remember step law is a tool, not a magic bullet.
Right.
It gives you a starting point, but you'll probably still need to tweak things and experiment a bit.
So it's more like a guiding principle than a rigid rule.
Precisely.
Okay, that makes sense.
Yeah,
So the researchers tested step law on all kinds of data sets.
it did.
But did they ever find a situation where it just didn't work?
Well, they found it to be very robust across different model architectures and sparsity levels.
Right.
But they did say there might be cases where it doesn't perform as well.
Okay, so like what would be an example of that?
Well, imagine you're working with a really specialized data set that's very different from anything they used in their research.
Okay.
Maybe it has unique statistical properties or a strange distribution. In those cases, it's possible step law's predictions might not be as accurate.
So it's important to be aware of the limitations. Don't just blindly apply a formula without thinking about your specific context.
Right.
Okay, so we've talked about the efficiency gains, but what about the actual performance of the models?
Yeah.
Does using step law mean you have to sacrifice accuracy for speed?
That's the really cool part.
Okay.
They found that the models trained using step law actually performed very close to the optimal settings they found with grid search.
So you're not really giving up performance.
Not really, you're just finding the best settings much faster.
So you really can have your cake and eat it too.
Exactly, and that's what's so exciting about this research.
Now we've been talking a lot about the benefits for like developers and researchers.
Right.
But what about the everyday people who use AI?
Yeah.
How could step law lead to better AI products and services for everyone?
I think it has the potential to really accelerate the development of new AI applications. And as those applications become more powerful and more common, they could have a huge impact on our lives.
So give me an example.
Okay, well, imagine personalized education with AI tutors that are tailored to each student.
Oh, that would be amazing.
Or healthcare systems where AI can help doctors make better diagnoses.
Yeah, what about entertainment or even scientific discovery?
Absolutely. As AI models become easier to train, we could see a ton of new creative applications.
Okay.
AI systems composing music or helping scientists analyze data.
It's not just about faster training.
Right.
It's about unlocking new possibilities.
Exactly.
But we also need to be mindful of the potential downsides.
Of course, we can't ignore the ethical implications.
Right. As AI gets more powerful, we have to make sure it's used responsibly.
Absolutely. We need to think about bias, fairness, and transparency.
We don't want to create AI systems that harm people or make existing problems worse.
Right. And actually, step law can help with that.
Oh, well, how so?
Well, by making AI development more efficient, it frees up resources that can be used to address these ethical concerns.
So it's not just about speed and performance. It's also about responsible AI development.
Exactly.
It's about making sure the benefits of AI are shared fairly.
I agree.
So step law is a big step forward, but it's just the beginning.
Yeah, there's still a lot of unanswered questions.
Like what?
Well, for one, we need to understand why step law works so well.
Yeah.
Can we explain it with basic math and computational principles?
So it's like we found this amazing empirical law,
Right.
but we still need to figure out the underlying physics.
Exactly.
That's cool.
Another area is exploring how to adapt step law for different tasks.
Okay.
Right now, it's mostly focused on language modeling.
Right.
But what about a computer vision or robotics?
So instead of training models to understand language,
Yeah.
we could train them to see or move or interact with the world.
Exactly. It opens up a whole new set of possibilities.
This is getting me really excited.
Me too.
But let's not get ahead of ourselves.
Okay.
We've got a lot more to cover in this deep dive. In the next part, we're going to take a closer look at some of the specific results from the paper.
Sounds good.
And we'll talk about what they mean for the future of LLM research and development.
I'm looking forward to it.
All right. We'll be right back after a short break. Okay, so we've talked about the potential impact of step law on, everything from AI development to scientific discovery.
Right.
But I want to get into the weeds a little bit.
Yeah.
The paper has all these charts and graphs showing how step law actually performs in practice.
Yeah.
What were some of the results that really jumped out at you?
Well, one thing that really impressed me was just how consistent step law was
Okay.
across all these different scenarios.
Right.
They tested it on models with really different architectures, like traditional transformer models, and then mixture of experts models, which are much more sparse.
Right.
And almost every time step law was really close to predicting the best learning rate and batch size.
So it wasn't just a fluke.
Yep.
It wasn't just oh, they got lucky with a couple of models.
Not at all. They even tested it on data sets in different languages and even code.
Really?
And the accuracy was still really good.
That's wild.
Yeah.
So it's not just about the model or the language of the data.
Right.
There's something deeper going on.
It seems like there's some fundamental principle at play here.
Okay, so we've seen that step law works.
Yeah.
But I'm curious, how does it actually compare to the old way of doing things?
Right.
In terms of saving time and resources.
Yeah, they compared it to the traditional grid search methods.
Okay.
And the results were really striking.
Okay.
In one case, step law found good hyperparameters in just a few hours. But grid search would have taken weeks or even months.
Wow, that's not just a little bit better. That's a huge difference.
It is.
That could really change the game for people who don't have tons of computing power.
Absolutely.
But, I have to play devil's advocate for a second. Isn't there a risk that if everyone starts using step law, it will stifle creativity?
That's a fair point.
What if it leads to this kind of cookie-cutter approach to AI?
Yeah, I think it's important to remember that step law is a tool.
Right.
It's not a replacement for human expertise.
Right, so it's still important for researchers to understand the basics.
Absolutely.
To experiment and to try new things.
Yeah, step law can help us be more efficient.
Yeah.
But it's up to us to make sure AI is developed responsibly.
Well said. I think this research has really opened up a new chapter in AI.
I agree.
It's given us this amazing tool But it's also raised some really big questions about learning and intelligence.
Yeah, as we keep exploring this field, who knows what we'll find.
It's a really exciting time to be working on this stuff.
It is. The researchers are actually going to release all of their data and models publicly.
Wow. So anyone can access it.
Yeah, imagine what people will be able to do with all that information.
It's like they've given us a map to this uncharted territory.
Exactly.
Now it's up to us to explore it.
And to learn from it.
It's not just about algorithms and data.
Right.
It's about pushing the limits of human knowledge.
Well said.
Well, this has been a really fascinating deep dive.
It has.
I hope our listeners learned something new about LLMs and the amazing research that's happening in AI.
Me too. And as always, we encourage you to explore these topics further.
Stay curious.
Ask questions.
The world of AI is always changing. There's always something new to discover.
That's what makes it so interesting.
That's a great point to end on. Thanks for joining us for this deep dive.
Thanks for having me.
Until next time.